Hello, my dear students and the rest of the learners. Welcome to part 17 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this presentation, we are going to look at what we call the user-defined functions or subprograms. My name is Meme JM, or you can simply call me Emily Swap. What are user-defined functions? The user-defined functions are those functions that are written by the programmer to perform certain functions or certain specific tasks. Most of the programs that are written by the programmers make use of the user-defined functions, even though one can also invoke a standard function within the code to perform a specified function. The following is the syntax and the examples on how to define void and non-void functions that are user-defined in C. We begin with void functions. Just as we discussed in the previous presentations in this series under subprograms, when you are writing a void function, you begin with the reserved word void, followed by the name of the function and optional parameters and closed in parentheses. And then we have the body, which contains of the opening brace and the statement be executed, each statement terminated by a semicolon and the closing brace. For example, you can have a function for entering the radius of a circle as follows. So the name of the function is read radius, and it is not supposed to return any value. So it is preceded by the word void and no parameters that are enclosed in the parentheses. And then we have the body, whereby we are defining a memory location called radius. We are declaring a memory location called radius for the value of type double. And then the next statement to be executed is the one which is going to display a text on the screen, which is enter a radius for a circle, and move to the next line. And then within the value of radius, and assign it the memory location called radius. So that is a void user-defined function. It is not returning any value to the caller or the sender. That's why it is preceded by the word void. So the format is the reserved one, that's the data type, the return type, which is void, meaning nothing is going to be returned, the caller, followed by the name of the function, which is read radius, and then followed by a pair of parentheses, which may or may not have any parameters. And then we have the opening brace, and then the body, which contains the declaration statements, and then the output statements and input statement, and the closing brace. The next type is the one which is for function which is supposed to return a value. We call them non-void functions. And the format is the return type, followed by the name of the function and the optional parameters, and then the body, which is composed of declaration statements and other statements for input and output, if necessary. For example, you can have a function for computing the area, and its format is as follows. The return type for this function, meaning the function called compute area, is supposed to return a value of type double. So the return type is double. The name of the function is compute area. Now this function is receiving two parameters. One parameter is radius, and the other parameter is bestowed the placeholder called pi, both of which are supposed to hold the values of type double. And then in the body, we have declaration of a local variable called area, which is of type double. And then we have the computation, which is telling the compiler or processor, pick the content in memory location called radius multiplied by itself, and the results gotten multiplied by the content in the memory location called pi, and store the results in memory location called area. And then send the value from the memory location called area back to the caller as the name of the function. So as you can see, Area is a local variable and the content in it is of type double, similar to the name of or the return type for the function called compute area, which is of type double. And then you have the closing brace there. Once you have defined your functions, my dear students and the rest of the learners, the next step is to call them with their core statements being organized in the order you would like them to be executed. This is done especially through the main program or the main function. Therefore, functions are called or invoked within the main function by just writing the function's name as a statement at the point where that segment is to be executed. This kind of a statement is called a call statement. It is the order in which you call your functions that determines how the flow of your program will be. This call statement also contains any additional information or what we call arguments that will be required by the function to perform the designated tasks. The following is therefore the syntax for writing a call statement for certain functions. The format is the function's name followed by optional parameters. Optional parameters simply means if you want to send certain values to the function, then you have to enclose those values in the parentheses as optional parameters. For example, if you want to invoke or tell the processor to compute or execute the function called read radius, which of course is of data type is void, meaning that it is not expected to return any value, then you just write the call statement as the name of the function. For example, read radius, and you enclose nothing in it. So simply, the call statements are like the headings, the header for the function. So these are call statements for a void function called read radius. Or if the function is supposed to return a value to the caller, then the value which is being returned should be assigned in a certain memory location. So in this case, this statement simply means that it's a call statement which is calling or invoking a function, that is function's name, and you are passing some parameters or some values into that function. And after computation or after execution, that function is supposed to return a value, and that value is going to be assigned in memory location called variable name. For example, you can have a call statement for a non-void function like read radius, which is going to read a value from the user, and that value will be returned back to the main, and the value will be assigned in memory location called radius. Now, call statement for a non-void function that sends a parameter and receives a value which is assigned to a parameter or a perimeter. For example, this one here, this is another function. This function or this call statement is invoking a function called compute area by passing into it two values. The value stored in memory location called radius and the value stored in memory location called pi. Once the function called compute radius receives these two values, it will perform the activity it's supposed to perform and then return the value or the result back to the main function where that value which has been received will be stored in memory location called area. The following is an example, is a sample program implementing 5 user-defined functions to prompt the user for radius, then computes area and perimeter of a circle and displays the results on the screen. So we have the comment, computes area and perimeter of a circle. And then we have the proposal directive there and what we call the global declarations. So the first declaration is declaration of a memory location called pi, which is supposed to hold a value which is not supposed to be changing of type double, and that value is 3.142. We are also declaring other variables here, which are perimeter, area, and radius to hold the value of type double. Then we have our first function here, which is void read radius. It's for entering the radius. This function is prompting the user to enter a radius for a circle. The user types in a value, which is stored in memory location called radius. And that is all. That's the first function. The second function is computing area. The name of this function is compute area. It's not expected to return any value back to the caller. And what this function does is to compute the value of radius multiplied by itself, and then the results multiplied by the content in memory location called the pi, and the results are being stored in memory location called area. That's what that function does. Then the next function is for computing perimeter. The name of the function is compute perimeter. It's not expected to return any value to the caller. That's why it has the sub-to-1 void. It's not receiving any parameters. Now this function will simply do the following. Pick the content in memory location called radius, multiply that value to the value in memory location called pi, and the results multiplied by 2. The value gotten is stored in memory location called perimeter. That's all with that function. The next function is for computing the area. The name of the function is output area. It's not expected to return any value to any other function, and therefore its work is it will display, or once it's executed, the process will display the following on the screen. The area for this circle is pick the content in memory location called the area, display it on the screen, but formatted as follows. Maximum 6 characters, but out of them, 2 be reserved for the fractional part. And that's all with that function. The next function is for outputting perimeter. The name of the function is output perimeter. It's not supposed to return any value to the caller. That's why it is preceded by the sub-to-1 void. What it does, it will display the following statements on the screen, or once these statements, or once the processor executes this function, it will display this statement on the screen. The perimeter for this circle is, it will pick what is memory location called perimeter, display it on the screen, but formatted as 5 characters, 2 of which should be reserved for the fractional part. And that's all with that. From there, we go to the main. Now, my dear students and the rest of the learners, this is where now we have to organize our core statements, and these core statements should be organized based on the order of importance or priority for the functions. Now, the first statement here is that this program demonstrates how to apply void functions. That's a statement which will be displayed on the screen. Then we have core statements, very important here. So the first function that is being invoked is read radius. So this is a core statement for the function called read radius. Once the processor encounters this core statement, it will go and look for the function called read radius. So the control will be taken here to this function called read radius. It will perform this activity. Once this brace is encountered, the control will be taken back to the main function and move on to the next line. The next line is a core statement to the function called compute area. So once this statement is encountered, the processor or the control will be taken to the function called compute area. So the control will be brought here. This activity or this statement will be executed, and once this brace is encountered, the control will be taken back to the main. And the next function to be computed or to be executed will be compute perimeter. Once this core statement is encountered or executed, it is telling the processor or the control to be taken to the function called compute perimeter. So that control will be taken to compute perimeter. That is here. Then it will perform this activity. And once this activity is executed and this brace is encountered, the control will be taken back the main program, where the control will be taken to the next line, which is output area. So once this function is executed, the control will be taken to the function definition called output area. So it will perform this activity here, and once this trace is encountered, the control will be taken back again to the main program. So we have said, once output area is executed or encountered, the control will be taken to the function called output area. Once this trace is encountered, the control will be taken back to the main program to the next slide, which is output perimeter. Once this statement is encountered, which is invoking the function called output perimeter, the control will be taken to this function here. This statement will be executed, and once this trace is encountered, the control taken back to the main program, and the next line, which indicates or tells the compiler to take back the control of the operating system and the program ends. My dear students and the rest of the learners, let us now own this program that we have discussed using IDE so that we can see how it will behave. So what we are going to do, we are going to launch Falcon IDE. So let's launch our IDE. Then once we are here, we are going to click on File, point on New, and then click Project. And the new project, we shall click on Empty Project and then click on Next. And then we are going to give our project a name. And this project, we are going to call it User Defined Functions. And the compiler is of type C. And then we click on Finish. Once we have our project name, you right click on it, point on New, and click on Save File. We then rename our C file to reflect the function of our file. So we are going to call it User Defined Function. And then we click somewhere outside there. Once we have our editor there, we then put our program here. So what we are going to do is I'm going to paste my program here, but my dear students and the rest of the learners were also free to type the program that we have discussed directly on the editor. So this is our program. This is the program that we have already discussed. You can see just a comment, then we have our global variables there that we are going to discuss later. We have our global variables there, and then we have our functions for entering radius, computing area, computing perimeter, computing area, the outputting area, outputting perimeter, and then we have our call statements there. So once you have coded your program and your functions, as we discussed, you can click on File and then Save All. Then browse where you want your program to be saved. And then, because you have clicked on Save All, we are going to save our project and all its files. You give your project a name, which of course can be picked directly, and then you click on Save. We can then compile our program by clicking on Run, then Compile. And you can see that our compilation has been successful. So you can click on Run, and then the execution or our program will be executed. And as you can see, this is our output statement already. This is our output screen. So from there, you can see it is only displaying the first statement, which is program demonstrates how to apply void functions. So from there, we can proceed and perform activities as generated. So what are we supposed to do? So you proceed as follows. As you can see, my dear students and the rest of the learners, is that our program is now asking us to enter radius for a circle. So if, for example, we type 3 and press enter, let's go back. Let's restart this program. We can compile our program. Then click on run. You can see we are being prompted to enter radius for a circle. So if you type 2, for example, and press enter, I can see that we have set it in a way that is going to indicate where to run up to. So I have to reset this program here. I will click on run to cursor. Let me take my cursor to the end there. And then I can click on run to cursor so that it does not pause, because I don't want to close this program and restart it. So if we are told enter radius for a circle, and then I click, you can see we are still being taken out. So allow me, my dear students and the rest of the learners, to close this program first. Let's close it, and then we reopen it. So close all, and then I can reopen it there. Let me also close the project. Close. Let me also close this so that we open our project afresh, and so that it is able to run correctly. So then we click on open, and then I select user defined functions. Click open. And then from there, here is our program. So I can compile it afresh. So I'll click on compile. And then I can click on run. Enter radius for a circle. I can type 4 and press enter. You can still see there is a problem there. So what I'm going to do is I'm going to avoid this aspect of running to line or running to cursor. If I click on execute, let's see, if you type enter radius for a circle and press enter, you can also see that our program is terminating prematurely, and therefore I'm going to close this program and restart it afresh, so that if there's an error, we can debug it. So let us rerun this program after restarting our program. My dear students and the rest of the learners, if you are trying to run your program and you find that it is malfunctioning or misbehaving, yet your code is correct, it's always advisable that you restart your program, especially if the termination is occurring unexpectedly or if the program malfunctions or hangs. As you can see, I have not changed anything in this program. I have closed my Falcon IDE and reopened my program, and this is our program. So always remember to save your program if you have not saved it. And you select the location and you save, which also includes saving your project. We can then compile our program again. So I'll click on compile. The compilation is successful. My dear students and the rest of the learners, kindly note, you have our comment there. We have our pre-processing directive there. We have our global variables here, which are going to be accessed by all these other functions. And then we have the first function for reading radius. We have the second function for computing area. We have the third function for computing perimeter. We have the fourth function for computing the area or outputting the area. We have the fifth function for outputting perimeter. And then, of course, we have the main function, which contains the core statements. And then we have organized our core statements in the order in which they are supposed to be executed, just as I've explained. And therefore, the next step to carry out is to compile the program. You can see our compilation successful. Let us now run our program so that we can see whether the program has stopped malfunctioning. Good. So you can see we have the comment, program demonstrates how to apply void functions, just as you saw in the main program. That is the first statement to be displayed. So the next statement is enter radius of a circle. So this is already the work of the first function. Once we enter that value for radius, we expect this program to proceed. Compute perimeter, compute area, display perimeter. So the statement we expect to see is a statements for displaying the area and the perimeter. So if I enter, for example, 2 as the radius and press enter, you can see all other functions have been attended to. The area has been computed, and we can see the output for area, which states the area for this circle is 12.57. You can also see that the function for computing perimeter has done so, and now the function for displaying the perimeter is giving us the message that the perimeter for this circle is 12.57. My dear students and the rest of the learners, you can see that even if you have very many functions, the only functions that you can be able to see their output on the screen are the ones which are for outputting. Like we can see the function for outputting area, that is the one which has given us the message, the area for this circle is that, and the function for outputting perimeter. Otherwise, the functions for doing internal computations will work behind the scenes. We cannot see that ourselves because that's the work of the processor. And therefore, my dear students, once you are done, you can press enter. Let's run our program using a different size of radius. Enter radius of a circle. I can enter 10. Once you press enter, you can see it is telling us the area for this circle is 314.20, and the perimeter for this circle is 62.84. So that's how we make use of functions, more so the void functions, the void user-defined functions to perform various operations or computations. You can press any key to continue and then save all. Click on File, close all, then we can exit from our IDE and go back to our presentation. So that's how our function, that is user-defined functions, but more so the void functions, will work. And with that, my dear students and the rest of the learners, we have come to the end of part 17 of the series, in which we have learned about user-defined functions, with our focus mostly being on what we call the void functions. And therefore, you can proceed to part 18 of 29, in which you are going to pay attention on some of the things that we have come across in this presentation, though we have not explained them. And that is where we are going to understand what is variable scope, what are parameters, and what we call parameter parsing. Congratulations for learning part 17 of 29 on user-defined functions, or what we call SubPrograms, in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer ICT videos, by clicking or tapping on MLSUP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video on YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 18 of the series, and God bless.